Okay, so we want to find the radius of gyration of this object about the y-axis. Okay, so the equation that we're going to use for this, and really what we're going to define this by, is we're going to, just like we've done with the um, like centroids, we're going to find a disk like so. And this disk is going to have a thickness of dy, okay? And it'll have a radius of, that would be x, okay? And what we're going to do is, because that's a disk, it has a moment of inertia of 1/2 mr squared. So to find the moment of inertia of the entire thing, I'm going to basically sum up an infinite number of disks, okay? So I need to find the moment of inertia of that thin disk, which is going to be, Iy, okay? And again, for a disk, it's 1/2 mr squared. So I'm going to, instead of m, I'm going to use dm, okay? And so I need to find the infinitesimal mass of this disk. Now, that dm, infinitesimal mass, is going to be the density of the material times the volume of that material, okay? And that volume is going to be the volume of a disk, which is going to be pi r squared, okay? Where r, for our case, is x, right? That's the radius of that disk from, is the distance x, times the height, which is dy, okay? Now, let's take a second, because it gives me the specific weight of the material, and it gives me that in pounds per cubic foot. Now, I need to get this in terms of mass, so I need to convert from pounds into slugs, okay? Specific weight is usually gamma, and it's, again, 380 times pounds per cubic feet. Now, the other thing, I not only need to go from, one slug, which is equal to 32.2 pounds, to convert from pounds to slugs, at least on planet Earth, that's what it equals, okay? I also need to go from feet to inches, because again, you'll see that our units here are in inches. So I don't want to mess with the units or the equations there. So I'm going to go, rather than pounds per cubic foot, I want to go slugs per cubic inch, which gives me 1 cubed foot cubed equals 12 cubed inches cubed, right? So don't make the mistake of going 1 over 12. It's actually 1 over 12 cubed to get this. From this, I then find the density, right? Because now I've basically gone from specific weight to density, at least on planet Earth, and I get 0.00683 slugs per cubic inch. Okay, so now I have dm, which is what I'm going to use to kind of figure this out. So I'm going to go back up to my equation here, and I'm going to start plugging in values that I know. So I get 1/2, and then of course dm, we just found, is rho pi x squared dy times r squared, which again is x squared for our value here, right? Because again, for our disk here that I'm finding, the radius is x, okay? Now, I want to make sure that I take into account the fact that x equals y cubed over 9, because I need everything, because I'm integrating with respect to y here, okay? So I need to get everything in terms of y. So let me rewrite this, reorder it a little bit. This is going to be 1/2 rho pi, and then it'll be x to the 4th, where x is y cubed over 9 to the 4th, and then that's going to be times dy. Okay, so what I do now is I basically integrate this. So to find dy, I'm going to take an integral. I'm going to pull up my constants out, right? So I get rho pi over 2, pull that out. So again, rho is 0.00683, okay? And then pi divided by 2, and then I'm going to integrate, well, not 2. I'm also going to pull out the 9 to the 4th. So let me leave it like that. We'll go pulling out all those constants, okay? And then all I'm left with in there is y cubed to the 4th power, which is going to be y to the 12th dy. And again, I'm integrating this respect to y, so I'm going to go from 0 all the way up to 3 inches, because that's the height of this guy, okay? Doing that integral, y to the 13th over 3, okay, and I get the value of 0.201. That'll be slug inches squared, which is a weird unit, okay, but that's what we have. However, this is wanting me to find the radius of gyration, which is defined as the square root of I divided by m. So now I need to find the mass of this entire object, and I do that because, again, I know that my mass, I can just integrate dm, right? And I have dm already, so I'm going to put in rho pi x squared dy, because that's what dm is. And then I'm going to plug in what I know x is equal, get everything in terms of y, and I'm going to integrate from 0 up to 3. Rho is 0.00, missed a 0, 0.00683 pi, and now instead of x squared, I'm going to use y cubed over 9 squared dy. Okay, and this big thing tells me that the mass of this, when I add up all of the dm's of each of those disks, the total mass of this guy is 0.0828 slugs. Plug that into here, I get the square root of 0.201, and I divide that by 0.0828, and I get the radius of gyration equal to 1.56 inches. Now, what is the radius of gyration? Well, the radius of gyration is just, again, the units are so weird, a slug inch squared. This is just a way to get it into units that make a little bit more sense. And what it's equivalent to is the moment of inertia of a ring with this radius, okay, with the mass of 0.08. So it's basically an equivalent ring of similar mass. What is the radius? What would it be? And you can see 1.56 is in between 0 and 3. So it's equivalently like putting all of the mass at a fixed distance away, which would be a ring. That's what a radius gyration is. Just another way to describe it, giving us units that make a little bit more sense to us. But again, the way we need to do this, break it up into a disk, knowing a disk is 1/2 mr squared, you basically find the mass of the infinitesimal disk, add up that using an integration to calculate the mass moment of inertia that I've got here.